There's a lot of JavaScript runtimes, like a lot of them. Porphyr, V8, Node, Deno, Bun, and many, many more. I'm not even talking about the weird platform-specific stuff like Workerd just yet, but we're going to get into all of that and more. Why, though? Why are there so many runtimes? Why are we not all just using one? What's so special about one runtime that makes it more useful than another one? Why do we care in the first place? It's just JavaScript, right? Why is so much time going into making all of these different engines? There's reasons for all of them, and this article is going to break down all of it, and I'm very excited to go in. If you're a nerd about JavaScript or you're just curious why we have so many different solutions, this video will hopefully be useful for you. I've been a nerd about engines for a while. I've even caught mistakes in articles about V8 from people who work on Chrome. I don't know, I'm nerdy about this stuff, okay? This is going to be one of the bigger, nerdier deep dives that I've done recently. So for those of you who like when I pull up Excalidraw and get weird about deep tech stuff on the browser, you're going to like this one a lot. That all said, these videos tend to take a lot more time to make and edit, and someone's got to cover our costs. So quick word from today's sponsor, and then we'll dive into the absolute chaos that is the current state of JavaScript engines. If you have no users, you can skip this part. But if you do have users, you know how important it is to have authentication set up right, especially if you're trying to onboard businesses. Big companies will try out products by small teams now, but they won't do it if they can't set it up. And if they want to set it up right, they're probably going to be a lot happier if you are using WorkOS. These guys get enterprise auth. They really deeply understand what these big businesses need, but they don't compromise on the developer experience that you and I expect. There's a reason why big business enterprise-y types like Carta and Plaid are using them, as well as more modern cool things like Vercel, Cursor, and more. WorkOS is the auth platform of choice for all of these companies and more because they understand both sides, what we want as devs and what these businesses need in order to integrate. The admin portal would be worth it by itself. You literally just send a link to the IT guy at the company that wants to integrate. They click the identity provider they use and they're good to go. If you've never had to set up Okta or SAML yourself, you don't know how painful this is. And if you have, I'm so sorry, you're probably already signing up. If you've been around for a bit, you know how quick Sam Lambert is to blast things and tear them to shreds. For him to be a testimonial on the site says a ton. When I asked the team, how was the experience with WorkOS, they were just like, this is incredible. And he's far from the only one that said that. WorkOS is so good that we're in the process of moving T3 Chat over to it now. And honestly, I wish I started there because the first 1 million users are free. What do you have to lose? Check them out today at soidev.link/workos. Just as a fun mini game to start, I want to see how many I can name. There's Quick.js, Node.js, Workerd, Deno, Bun, Porphyr. Fuck, what's the one in Firefox called? Does WebKit even count? I guess it's JSC. Technically, it's what Bun's built on, but that's like more an engine. There is a distinction between engines and runtimes to an extent. Hermes didn't come to mind immediately because it's also kind of a like compiler and a JIT thing, but it absolutely is a JS runtime. What are the older ones? There's the one Amazon did. Fuck, what's it called? LLVM, right? It was built to make Lambda faster. Fuck, I can't remember the name. I don't think it's LLVM. It's something like that. LLRT. Thank you, chat. I did look. I had to cheat a little bit. Can I come up with more off the top of my head? I think I might have to tap out here. There's a lot of older ones. I can't remember the name of the Firefox one. Okay, I did pretty good, all things considered. I'm proud, but I haven't covered why we did all these in the history of how we got here, and that's what this article is for. Thank you to Jamie for writing this and inspiring this video. I have a feeling we're going to love this one. This last decade has seen an inundation of new JS runtimes and engines in equal measure, enabling us to run JavaScript in all the manners of contexts with precise fitness for tasks. Through these, we've seen the language spread to the cloud, the edge, smart TVs, mobile devices, and even to microcontrollers. In this article, we'll explore what's driving the diversity and why no one runtime or engine suffices for all purposes. Edge computing. The first consumer edge computing solution was introduced in 2002 by Akami, which enabled building on the edge using Java and .NET. But it would be a long time before JavaScript would join those languages. For one thing, JS wouldn't be useful as a server-side language until Node emerged in 2009, and for another, Node wouldn't be employed in a serverless context until Lambda in 2014. It was only with the announcement of Lambda at Edge in preview from December 2016 and then released in March 2017 that JavaScript would finally be seen on the edge, again running on Node. But Amazon's monopoly was to be short-lived. For just 6 months later came the release of Cloudflare Workers, a purpose-built minimal runtime revolving around the Service Worker API. It was devised to open an entirely new market to Cloudflare, compute and storage. And this was notably different from Amazon's venture. For the first time in the over 20 years since JS's inception, a company had managed to directly productize a JS runtime. Let's break down what that means quick, because if you haven't kept up over the years, it might be hard to understand. If I have the globe, very realistic representation of Earth that I've drawn here, and I have a user, and that user is over here, and you have servers for your product, and those servers are over here. The user makes a request to your service, and then your service generates a response and sends it back to them. And there is a distance that that request has to go, and that distance can make it pretty slow, especially if the user has to do multiple back and forth. If it's just one back and forth, it's slow and annoying, but fine. But if they have to do like 2 or 3 more, every single additional one that has to be done is an additional round trip that additionally massively increases the time until the user sees a response. As such, there's been a desire for a long time to figure out how to reduce this distance, how to get this closer so the total distance traveled goes down. So ideally, you get close to the user and now way less back and forth has to happen versus over here where there's way more. There's a problem though. Nothing is actually this simple, as much as I would love for it to be, because this is the thing that's running your code. This is your server, but there's another box that matters, your DB. In an ideal world, your server and your DB are so close that the arrows connecting them are effectively invisible because they are so tiny. And if you move these around, everything makes sense. When the server and DB are further away, the amount of time it takes to complete a request is higher. When they get closer, it's lower. But chances are your database is centralized because most databases are. So if this is here, you end up bugging out Excalidraw a whole bunch because arrows are hard. But more importantly, you've just moved that back and forth. That said, if you can make it so that you don't need to do a lot of database back and forth for a given request, you can make this work significantly better and get the user something faster. But if you put it close by here, the amount of time it takes before the user sees anything is relatively high. There's a lot of incentive to do things like putting this here, and it's often that you have lots of different servers and databases. Let's say you have one here, one here, one here, and you want to make sure the user's going to the right one. Maybe you move this really close to the user, and then this server sends something to the user immediately, like a static template, so they get some content instantaneously. And then this edge server will redirect traffic to the place that makes the most sense. Maybe it's here because it's closest, or maybe it's all the way down here because that's where the user's data actually is. The place that it goes can be determined by this edge server. The problem is that that edge server has its own weird set of complications and restrictions. If you have hundreds of these edge servers all over the world, they all need to have your code in order for the user to get anything and have their traffic directed to the right place. If you're using Lambdas, the traditional serverless solution, you have one region in one place that has your code running in it. And if there isn't a box already running it, it will spin it up. It might take a few milliseconds. It'll probably take a few seconds, make all the connections it has to, and then resolve, and then sit around for a bit to see if more requests come in. If 10 users request your service on Lambda, most of them are hitting an already warmed Lambda that has your code. If 10 users hit an edge server, they're all hitting different edge servers almost always because there are hundreds of these across hundreds of locations, which means the likelihood you're hitting a warm server is nearly zero. The result is that the majority of requests will be cold versus with Lambda, the majority of requests will be warm, which means that the spin-up time, the amount of code that is necessary to run this box, and the amount of things you want running at one time on this box, those are all very different than they are with Lambda. Because with Lambda, it's basically spinning up a server temporarily and keeping it around until no requests come in, then dying. With edge servers, each request is instantiating your code, creating an instance for it, and killing it per request. That is a very different model from how V8 works. And as such, V8 doesn't work well in edge environments. The nature of edge requires that your cold starts are really good, that your bundles are really small, and most importantly, you need to be able to resolve those things quickly on boxes that have very, very little compute. The actual performance of an edge server versus like a base tier Lambda, it's like 1/5 the CPU power. If you're trying to render a really complex web page on Cloudflare, it's going to take way longer than it does on something like Vercel or AWS because they have better CPUs on the boxes and you're getting more of them dedicated to your request. As such, if you take the engine that works well on your normal server and throw it on the edge, everyone loses. But there are a lot of benefits to these edge servers that are worthwhile to figure out. And this is why I often refer to them as glorified switch statements, because they're really good at resolving something with a small amount of code close to the user. But you need a runtime that can handle that, which is why worker D was invented, and it's why they abuse service workers the way they do. They found a way to not give every single developer their own V8 instance. Instead, the V8 instance is shared, and every request spins up a little bit of code as a service worker in that V8 engine to resolve that request. So we think of the server as an engine. So we have the V8 engine here. If you're doing this on Vercel or Lambda or any of those other solutions, every developer gets their own V8 engine instance. So let's say we have developer 1, developer 2, and developer 3. All of them have their own V8 instance. Maybe some of them have multiple V8 instances because they have enough users. And then when a user's request comes in, the whole V8 instance is being used to resolve this user's request. And then the result goes out. This means that every single one of these devs effectively needs their own full virtual machine. So it's running Docker in its own Linux instance, even if virtualized. It then has to run its own JavaScript runtime and V8 engine in it. And then the request goes on top of all of that. So you have like the V8 layer, you have the VM layer. So this is like Docker or whatever. All of these have that as well. And then maybe at the bottom here, you have the real server. And the real server might be a shared thing. So even if all of these devs are publishing their code on Lambda and the same real server is resolving all of their requests, they're all in their own VMs and they're all in their own V8 engines. This is where things get different with the way that Cloudflare does it. On Cloudflare, there's still a real server. It's a lot weaker a server, but there's still a real server. But we don't care about the VM anymore because all of these are running in the same VM instance. You don't control the VM really at all. They just finally on Cloudflare put out their own Docker thing, and it's really, really expensive because that's not the thing you're supposed to use on Cloudflare. It's not what they're good for. Where it gets really crazy is on this V8 layer because all of this is also the same instance. And instead, each developer's stuff runs in its own separate service worker. And the service worker instances all are effectively running inside of V8 together. So dev 1 has this code, dev 2 has different code, and dev 3 has maybe 2 different types of code for their service. Maybe they have this one, maybe they have this one too for different users. But all of this is running on the same real server, in the same VM, in the same instance of V8. It's just separated via service workers for each of these JS files inside of it. They've done a ton of things in order to make this run as well as it does. And obviously, there's a bunch of versions of this stack, different places around the world. There will literally be like thousands of these across the world to handle your services. But the V8 instance is already running when the request goes in, but it's running a bunch of other people's code. And then your code just gets stuffed in as the most recent thing, as a new service worker. And then when it's idling or waiting, other people's requests can come in. The cost is that they're way slower and you can only fit so much into one of these instances. And since you're sandboxed into these tiny service workers, you can't hit the VM. You can't call FFmpeg. You can't do things that require editing files. You can't do anything outside of the engine, but it's magical what you can do when you use it this way. Hopefully this has helped make it clear why Node and Worker D are entirely different runtimes that both need to exist for different reasons. And that's just one of the runtimes we're here to talk about. Let's keep digging. Cloudflare Workers were a phenomenal success with billions of tasks running in the half year following its beta release. The scent of opportunity triggered a gold rush. Deno appeared shortly after in 2018 as a challenger to Node, and within 3 years, Deno Land Incorporated had formed, launching Deno Deploy, an edge network intended to chase after Cloudflare. With an initial treasure chest of 4.9 million and then raising a 21 million Series A round next year, it's clear that Cloudflare weren't the only ones who believed in the value of this niche. The rush continued in 2022. No sooner had Winter CG been formed to start defining a common ground for those JavaScript runtimes popping up than Bun appeared, quickly raising 7 million to provide serverless hosting, continuous integration, and edge computing. Oh boy. Yeah, if you're not familiar with Winter CG, it's an attempt at doing a standards group for server runtimes for JavaScript in order to make sure that all these different server runtimes are, for the most part, compatible. That if we add server-side fetch, that it'll work roughly the same across all these different runtimes, so that if you make a package for servers in JavaScript, that package will work on Cloudflare, as well as in Node, as well as on Netlify, as well as in Deno, as well as in Bun. We need a standard in order to do that. Wasmer followed suit in 2023, stepping into the service worker arena with Winter.js and Wasmer Edge. And not to be outdone, the very next year, AWS responded with the low latency runtime, which is another low latency runtime, just right for the Edge. This is what I was trying to remember the name of, and I very stupidly said LLVM because my brain doesn't work. I was the only person who had covered LLRT for like a month. I remember searching for it on YouTube and having the literal only video on it, except for a random like a Brazilian like news aggregator thing, for literally 3 weeks. It was kind of cool. That was one of those like, oh, my channel is still very novel. I'm covering things no one else will, as we are here. Who else is going to dig into every single JavaScript runtime? I'm not saying this content is super valuable. It's just something I happen to really like, and I'm thankful you all are watching this far in. Anyways, for all the overlap in strategy, notable is the variety in engines underpinning these runtimes. While Deno and Cloudflare workers, which run on workerd runtime, all continued Node.js's tradition of using V8, we see Bun employing the JavaScript core, which is the runtime that was built for part of WebKit and Safari. Winter.js is using SpiderMonkey, the original JavaScript runtime, and LRT is built on top of Quick.js. Quick.js's goal is again to be as fast and small as possible, which is great for doing things with really quick spin-up times. Again, part of the problem with Node is that it expects that it's already running when you send a request to it. So if you have to spin it up every time a request comes in, that's a lot of time to eat per request. If you want to reduce cold start time to as low as possible, you need to be able to either lower the amount of code and things that have to be hit to spin up the runtime, or you need to already have a runtime running and stuff something else into it that's well isolated. And Quick.js is an attempt at doing the prior, making a really small runtime that can spin up almost immediately. It's like literally 2 megabytes. This is a fun change because previously, if you were using JavaScript on the backend, you had to use Node and V8. Now it's cool to use different runtimes and engines instead. Cool. That's the edge section. Hopefully that was a good, useful info dump for you guys. Now for something that I don't know jack shit about, microcontrollers. Many of the above runtimes would have a hard time running on a microcontroller, though. For the unfamiliar, AWS defines them as follows. A microcontroller is the basic computing unit inside of smart electronic devices, like washing machines and thermostats. It's a very tiny computer with its own RAM, ROM, and I/O systems, all embedded on a single chip. It can process digital signals and respond to user input, but its computing capacity is limited. At the low end, microcontrollers may cost as little as 3 cents, have mere bytes of RAM, run in under a milliamp of current, and have an 8-bit architecture and or have under a kilobyte of storage. Yeah. So it's like your average Android phone. I'm sorry, I thought that was a good joke. Nobody, come on, guys. Give me one. Let me have this. That was funny. As someone who just spent $1,400 on a Pixel Fold and hates it, I've earned the ability to make fun of Android. I spent money to make fun of Android. Yeah. And to be fair, my Pixel Fold doesn't feel like it costs as little as 3 cents. It feels like it costs $1,400 and it runs like it costs $50. Anyways. Given these specs, full-blown Node would be well out of the question for a microcontroller. So many took to producing slim as possible engines. Duct Tape, Esperino, I'm assuming that's for Arduinos, as well as MJS in 2013, JerryScript in 2014, Moddable in 2018, and Elk in 2021. These projects pride themselves in running on under 64 kilobytes of RAM. In fact, apparently little more than 100 bytes in the case of Elk. Elk's a JS runtime that runs in 100 bytes. Okay, I'm not gonna lie, this is kind of cool. As a person who mostly lives in JavaScript nowadays, even if I'm an aspiring Elixir dev, there's no way Elixir's running on a fucking microcontroller either. As a shared syntax for this is really cool. Also, on a similar note, I gotta plug one of my investments quick. My friend from college, Sevi, is building a very cool startup, TS Circuit. It's an open source set of tools for using TypeScript and React to design PCBs. So you write React code with a set of JSX components they provide to define the board, define arrays, map LEDs on, all those types of things. So you can write React code to churn out an actual circuit board. It's actually super cool, and I was very excited to invest in him when he told me he was going all in on it. Sevi's one of the smartest people I know, was like the cool kid when I was in college, like the cool nerd to be clear, but he was like the one we all wanted to be like when we grew up, and now he's doing really cool shit here too. I was pumped to write him a check. If you're nerdy about these things too, you should give TS Circuit a look. One of the really cool things about this is that AI is not good at doing circuit board design because it can't edit the image or deal with the weird 3D software used for all that. But AI is really good at shitting out code. It's really good at shitting out React. So if you give it a React syntax to generate a circuit board, all of a sudden you can vibe code circuit boards. Really cool stuff. Shout out to Sevi for that. There's a lot of cool innovation going on with the JavaScript world inside of this crazy Arduino microcontroller circuit board shit. It's really interesting. Just wanted to go on a quick tangent there because I think it's cool. Shout out Sevi. Back to the article because I'm really enjoying this. These engines then spawned new runtimes, though not necessarily serving the very lowest end of microcontrollers. Jerry's script underlies IoT.js and Microlattice, both Internet of Things runtimes. We should probably define the difference between a runtime and an engine. That's a pretty good explanation. Thank you, T3 Chat. I bet the guy who made this is really handsome and hardworking. The engine is the part that implements the actual spec and the standard. It takes the source, parses it into an AST, maybe compiles it to bytecode and executes it, handles memory and all of the above. The runtime is effectively a wrapper for it that is focused on providing all of the integrations you would want, access to the system, APIs, all the other shit that you have to do. Even things like set timeout and set interval are usually done at the runtime level, not the engine level. Hopefully this helps you get an idea of the difference between the two. Thank you, T3 Chat, for making it easier for me to explain that. Ooh, I've never heard of Low.js. Apparently it is an attempt at a very minimal node. Yeah, a port of Node with far lower system requirements. Community version of POSIX systems such as Linux, UC Linux, or Mac OS X. Low.js is a free-to-use and open-source port of the JS runtime Node with far lower system requirements, allowing it to run on cheap, power-efficient microcontroller boards based on the ESP32W Rover module. It also runs on Linux-based systems as a smaller, faster booting alternative to Node. That's really cool. There are so many of these. It goes to show that venture capital needn't be a lure to develop a JS runtime. Sometimes people just want to run JavaScript on a device, no matter what. And sometimes they want to call JavaScript even when working in a different language, which brings us onto our next topic. Oh boy, there's someone who's going to have a lot of feelings on me talking about this. A guy I've met at a lot of parties that thinks a lot about these polyglot engines. Oh boy. Although most JS engines are based on a bespoke virtual machine used only by the engine themselves, some are based on established VMs, enabling zero-cost interop with other languages. In this space, C++ isn't necessarily king, and it's interesting to see how many ways there are to write a JS engine. So what this means is the same engine can run different code from different languages and interop and share values and memory and processes between JS and whatever else at no cost. This is part of what changed with recent versions of React Native, where they got rid of the need to have the JSI bridge and instead values just shared because the engine is interoping in a really powerful way. It's not truly a traditional polyglot, but it's close. Hermes is crazy tech. Let's just go through what the Polyglot Engine history is, though, because I actually don't know the history of this part of things. The original Polyglot Engine was Rhino, which was made in '97 as an effort to write Netscape Navigator, the JavaScript engine and all, fully in Java. Very interesting. I was 2 years old at the time. This is going to be fun for me because I learned a lot about runtimes through Java in weird ways. Both when I was younger, hosting Minecraft servers, learning about JDK and OpenJDK and all the different ways to run Java, and the Android world chaos there of Google re-implementing a lot of Java and getting sued. But also when I was working at Amazon, I had a bunch of slow Ruby code that we were trying to get running on the Java virtual machine, the JVM, through a thing called JRuby, which was a full Ruby runtime implemented in Java to run on the JVM. Crazy stuff. I've been through it with Java. The concept of a runtime as we now understand it largely comes from Java, and as much as we like to shit on Oracle here, believe me, we do. They deserve credit for this in particular, and it's funny that in '97, there was an attempt to write a whole browser from scratch in Java, including all of JavaScript. Rhino supports two-way interop between Java and JS, all based on the JVM. That is to say, it allows for JavaScript to implement Java interfaces and call Java class methods, while allowing for Java to define JS classes, run scripts, and more. By 2006, it was included in JDK 6, and by 2008, it was the basis of the Helma runtime, nowadays known as Ringo.js. Because Ringo's known for being the best of the thing he's part of, right? That's a good sign. No commits for 2 years and various that have been not touched for 14. Very interesting. I would not touch that with a 100-foot pole. Cool that it exists, though. Apparently, it was superseded by Nashorn in 2014, and then it got superseded again when JDK 11 dropped in 2018 with Graal. I know Graal very well. Graal.js is a fascinating project. Again, JavaScript runtime built on top of the Java VM. Graal is a much better JVM. Apparently, Graal supports both. This is an interesting line of history. All being Mozilla and Oracle projects, these three may be the only JS runtimes rightfully allowed to use the JavaScript trademark, pending Deno versus Oracle. Oh man, that court case has been fun to watch. For those who don't know, since the name Java is in JavaScript, Oracle has maintained a trademark for it. Oracle doesn't release anything related to JavaScript, but they will sue you if you use the name too often. There cannot be a JavaScript conference because Oracle will sue you if you make one. You have to call everything JS, because if you say JavaScript too loudly, Oracle will come at you. Yet another reason to use TypeScript, am I right? Anyways, Graal.js well deserves its seat on top. However, going as far as supporting the whole Node SDK, by virtue of embedding the entire code base. That's hilarious. Graal Node just dumps all of Node. That's hilarious. The lineage is just the tip of the iceberg, though. There's Gent for .NET, written in C#. There's PyNarcissus, LangJS, and Jispy, all for Python, so you can run your JavaScript code in the Python runtime. There's Two-Stroke and Opal for Ruby. Don't run JavaScript in Ruby. JavaScript's faster than Ruby. There's Elsa for Go. There's Boa, Toy.js, Arquick.js, Spiderfire, Nova, and Jaws, all for Rust. Ooh, Jaws is a new one. It's a JS to WASM compiler. Oh, apparently it's JAWSM now. It used to be Jaws because it's WASM. That's clever. Then there's Kiesel for Zig, and the list surely goes on. Though arguably not all of these are fully polyglot, some are merely interpreters and don't offer two-way language interop. JavaScript engines are even being implemented in JavaScript. Narcissus, originally built by Brendan Eich, who also created JavaScript in the first place, was built and used by Mozilla as a testbed for rapidly prototyping new JS language features. JSComp followed in 2015, which was an ahead-of-time compiler written in JavaScript that generated C++ executable code. More recently, Oliver, Canada Honk. I wish they were here. One of the smartest people I know, and I'm very lucky to have them in my DMs correcting all my stupid mistakes before the videos go live. Oliver is a fucking legend. And Porfer is one of the few of these new runtimes that I'm actually hyped about because Canada Honk knows what they're talking about. Let's just say that for the least. I have a whole video on Porfer, and I've gotten even more hype since. Great dev, great incentives, great work. Awesome seeing them called out here. Was wondering how long it would take. Porfer is really interesting because it's a JavaScript runtime written entirely for WASM. Why would you want to run JavaScript in WASM? Okay, hear me out. You end up with something way smaller than Node. So if you're trying to build a game, for example, like you want to build some fun game you want to put out on Steam, and you wrote it in JavaScript, now you have to ship all of Node as part of the game when you ship it. Or you use something like Porfer, and you're shipping a few megabytes instead of like 300 plus. Very, very exciting. Porfer's WASM output is 10 to 30 times smaller and faster compared to existing JavaScript WASM projects, and it's comically smaller than shipping all of Node. Yeah, and the native implementation goes from 90 megabytes, for an example, to under 100 kilobytes, with potential for other performance benefits too. And I'll be honest, if anyone else was making this, I would be really, really skeptical. But Canada Honk is on the JS steering committees and is also the creator of Test262, which shows how compatible every JavaScript engine is with the JavaScript standard. Incredible resource. The fact the same person's making this and Porfer gives me so much hope for where it can go. Anyways, there are other engines here too, though, like Shadow, which was written in JavaScript. While starting out as a hobby project, Porfer has shown such worth as to attract financial support from Chris Wansdorf, enabling Oliver to work full-time on it as of 2024, leading to 58% conformance score on Test262 less than a year later. Worth mentioning that Oliver's the person who made Test262. I get why that would be missed. Regardless, very hype. The demand to call JavaScript from other languages and even build new JS engines in it underlies the strength of the ecosystem and the ergonomics of the language. Though nowhere is this ecosystem advantage as clear as it is in the world of native apps. Oh God, this is going to be the React Native section, isn't it? I'm scared. I'm really scared. People are going to be very angry in this comment section. I can already tell. Actually, the people who leave shit comments tend to stop watching about 30 to 45 seconds in, so very good chance they're not here still. Fingers crossed. JavaScript's web origins make it a language well suited for building graphical user interfaces. And so it was only a matter of time before it began being employed in native apps, often as a basis for cross-platform frameworks. A point of constant contention in this space is what balance to strike between fidelity to the web platform and fidelity to the native platform. So where better to start than the frameworks that went all in on web? These are the web views on mobile, which is funny because, as I'm sure he's about to say, the iPhone didn't even have an app store initially. They announced that the way you would build apps for iPhone was HTML5. The iPhone's release in 2007 set a new bar for mobile hardware, normalizing the use of desktop-grade web tech on mobile. With iOS, Android, Windows Phone, BlackBerry, WebOS, Symbian, Samsung Bada, Firefox OS all vying for market share at once, developing for just one platform posed a significant opportunity cost. In 2009, Adobe answered the quandary by releasing PhoneGap, a framework for embedding web apps into native apps via a web view, which of course included a JavaScript runtime. I need to run a poll. I know you guys are mostly young. Yeah, this is what I was scared we would see. I'm honestly surprised so many people have used it, but yeah. PhoneGap and Cordova were the OG ways to like build a multi-plat app that was a web app that you would package into a mobile app using PhoneGap, Cordova, and similar tools. There are still a couple of these types of things around. They're all failing miserably. They suck. They suck really hard. Yeah. PhoneGap proved popular, with over 23,000 apps being built on their build service, according to a contradictory chart, by 2011, and having been downloaded over 1 million times and used by over 400,000 developers by 2012. Along the way, it was open sourced as Cordova, and a UI toolkit was created for it, Ionic. Oh god, Ionic. I know way too much about internal drama at Ionic, so I can't go too much here without getting people in trouble. All I will say is that if you have the option to use Ionic, Capacitor, or Cordova, or you have a better option, like stabbing yourself in the eye with a fork repeatedly, I would pick the fork every time. That's all I'm going to say. On desktop, Electron, now a household name for WebView-based desktop app development, traces its roots back to Node WebKit, a project with release dates as far back as 2012. While the latter was originally based on Node and WebKit, it was renamed to NWJS in 2015 due to plans to migrate to Chromium, which was an effort that was completed in 2016. Electron's history runs alongside this. In 2013, GitHub began working on Atom Shell, which was an NWJS-like framework built by a former NWJS core contributor to be used as the foundation for the Atom text editor. While Atom itself would one day be sunset, Atom Shell would live on, being renamed to Electron in 2015. Although NWJS is an active project to this day, Electron has very much taken the limelight, coming to dominate the market for desktop apps, with many industry-leading apps like Discord, Slack, Linear, and VS Code all being based on it. This is one of my favorite pieces of history because I got to watch this as it happened. GitHub didn't have native application devs. They didn't have people who were experts at building native UIs and handling all the quirks of Windows and Mac. And they really wanted to compete with Sublime Text. And they saw a very clear path for doing that. And that clear path wasn't build all of the native bullshit yourself. The clear path was take advantage of the fact that everybody here knows how to build in the web and make it so we can build with the web on all these other platforms. The first ever Electron app was Atom. It's kind of funny to think, but that's how it got the name Electron, because it's part of the atom. Yeah, crazy. And now, smart TVs. This one's a bit of a disaster. Beyond mobile and desktop, there's also esoteric smart TV platforms. Many smart TVs run forks of desktop web browsers with additional APIs for interacting with native TV functionality, such as the broadcast stream, object carousel, remote control key sets, and DRM systems. I know way too much about the history of the TV stuff, in particular WebOS, which started as the Palm platform that invented most of the touchscreen UX that we expect now. Web-based smart TV specifications and platforms include OIPF, which is a interesting standard. The Open IPTV forum. God. I used to do a little bit of TV stuff, a lot of TV hacking. I feel trauma responses right now. Oh man. Yeah. There's also HBBTV, which is still active apparently, and ATSC3, which is 2016 onwards. There are also endless platforms with different SDKs, like WebOS, UView, FreeView Play, FreeSat, and much more. On some platforms, one negotiates with an infrastructure provider to serve an app over broadcast. On other platforms, one negotiates with the platform owner to have the app distributed with the device. And on others, like Android TV and Apple TV, one submits the app to an app store. If you wonder how TVs got so cheap, it's because of all of the weird buttons on the smart TV. Smart TVs will always be cheaper than dumb TVs because smart TVs are subsidized by dumb customers because they put the weird button for Tubi, for Peacock, for Netflix, and all those other things. Each of those buttons reduces the cost of that TV by around $10 to $15. So if you got a dumb version of the same TV, you'd be paying $50 to $100 more because it's not subsidized by those companies. There's also the Amazon Fire TV and Fire TV Stick, which are both based on Chromium, as well as the Samsung Tizen TVs, which have been since 2017 using WebKit. And all three of these employ Cordova. Oh God, that explains so much. Roku is different, with apps being programmed in BrightScript. Oh God, I have heard a bit about this from the team at Twitch that had to deal with the Roku app. They built their own language for it. BrightScript statement syntax is not C-like. In this way, it's similar to Python, Basic, Ruby, or Lua. Just imagine you're building a TV platform and you're like, you know what we need? Our own language. Ugh. I'm in pain. And while Apple TV used to offer a framework known as TVMLKit.js based on JavaScript core, it was not based on web tech beyond implementing a very small amount of the DOM spec. With more than 1.26 billion internet-connected TVs installed worldwide and HGB-TV devices present in over 100 million homes in Europe alone, smart TVs account for a surprisingly large segment of JS runtimes. Only through this common language in the ubiquitous web platform is it practical to deploy apps to the sheer number of different device types in the market. The chaos of these TV apps is hard to put into words. It's one of the more impressive engineering feats at Netflix is making all of that work. It's also a big part of why Primeagen hates React so much. Because imagine trying to get a fucking BrightScript Roku TV to handle React. Good luck. I wonder if anybody's built a JS runtime in BrightScript. I'm saying things that I don't want to look into. I don't want the answer to that because I really don't want the answer to be yes. And now, finally, a good thing. React Native. As the mobile landscape began to settle down to a landscape dominated by iOS and Android, oh, you mean Windows Phone isn't going to happen? That'll be another fun poll, actually. Did you have a Windows Phone? Yes, no, but wanted one. No, never wanted one. Windows made phones? So far, we have one vote that's yes. I could have had a very different life trajectory. I remember picking between the Droid and... what was the name? It was like a very much targeted at kids phone that was Windows Phone based on Verizon. They had two versions, one with a sliding keyboard and one without. It wasn't the Sidekick, it was a Verizon thing. It was the Kin. This. I almost got this as my first phone. And last second, decided to go with the Droid instead because it had more apps. And that changed the trajectory of my fucking life. I could have possibly not went down the dev path if I got this piece of shit instead. It would have just been yet another fucking feature phone. But instead, I got a smartphone that was a real platform and ended up learning a whole lot from that. This is a fun split. People actually owned a Windows Phone in my community. Maybe my audience is older than I give it credit. Yeah. iOS and Android won. There's no debate there. There was the moment, what's the name of the Firefox OS port or fork that's really popular? Is it still? Yeah, KaiOS. Does KaiOS still exist? Because this was the fastest growing mobile OS for a while. I'm pretty sure it's like it has to be dead by now. Smartphones have gotten cheap enough, but it was the like feature phone OS in a lot of other countries for a while. It was a fork of Firefox OS. All of the apps there are actually web-based and JavaScript-based, which is cool. And yes, the person asking about the Palm Pre, I already brought it up. WebOS is the craziest history. It invented half the UX that we love nowadays on our smartphones. Palm Pre feels so weirdly ahead of time for when it came out. But yeah, the Pre died hard. Fusisa's never happening. Lose hope. It's over. Google's never going to release a new OS. Anyways, I'm sorry. I will nerd out about mobile platforms forever. I've been fucking through it with the stuff. The reason I rock an iPhone now, it's because I'm an adult. Facebook announced a new cross-platform framework in 2015 targeting both of them, React Native. The framework enabled devs to write a React app that would render native platform views. This is the key piece. React Native is not embedding a web app into your mobile app. It is not Cordova or PhoneGap or Ionic or any of those things. It isn't putting a website in your phone. It's using JavaScript to tell the phone what native UI to use. That's why it's called React Native. It's using React to build a native app. It's not React Web in an app. It's React Native. And I wish people would understand the difference. There's effectively zero overlap between how Electron works and how React Native work. And if you see these technologies as similar, you don't understand either of them. React Native uses a JavaScript runtime that could call out to native functionality and respond to native events via posting serializable messages across a bridge. This has since changed, and I bet he'll get to that in a little bit. Initially, this JS runtime was based on JavaScript core, as it came included in the iOS SDK, and it's been there since iOS 7 in 2013, and that would save significant app size for iOS users. Being also heavily optimized for mobile usage, it was a smart choice at the time. However, after a few years of seeing how it performed in practice, Facebook would seek to improve upon it. And so in 2019, they announced Hermes, a new engine tailor-made for React Native. Hermes boasted an improved startup time thanks to various tricks like ahead-of-time compilation, which worked around Apple's ban on JIT. I have so many feelings on Apple's ban of JIT. If you wonder why your super, super powerful smartphone can't play emulators more powerful than like the PS1, this is why. There is no just-in-time compilation allowed on iOS. It's our belief that Apple banned it because of potential security issues, but in reality, Apple banned it because they don't have a reason to unban it and they kind of hate developers. As much as I love my Mac and my iPhone, and as much as I defend Apple, I will shit on them for how they run the App Store nonstop, 24/7. I hate it. Anyways, Hermes also allows for memory mapping of the bytecode into RAM. It's kind of crazy when you think about it that Hermes is a JavaScript runtime built exclusively because Apple's implementation of JavaScript on iPhone was bad, and Apple's rules around how JavaScript and other languages had to work on iPhone were even worse. This is a whole engine built around sidestepping Apple's shit decisions. It also cut down on bundle size for Android because JSC was not part of the system framework on Android, which also helped with memory utilization for both platforms. Hermes delivered so well on its promises that it was made the default starting in 2022, And Meta's even preparing a successor, Static Hermes, which is going to turn your code into native code. I have a long video about that. You should check that out at some point. It will support an arbitrary mix of native and interpreted code, both typed and untyped, to afford performance on par with C and C++. Hermes wasn't the only option explored, however. From 2018, React Native began implementing an engine-agnostic JavaScript interface, which, besides eschewing message posting in favor of direct native bindings, has enabled it to be adapted for use with various engines. JSI has been implemented for Hermes and JSC, V8 independently by Microsoft and Expo. You can see the Kudo Chien talk on that, as well as in QuickJS by Microsoft for a hackathon, and Chakra by Microsoft for use in React Native Windows, as Chakra is included with Windows. Yes, React Native is used in Windows, and they re-implemented the JavaScript interface in order to allow for the JavaScript and React Native code in Windows to interface with the native code more efficiently. Really cool that you can effectively now just like share values between the native code and the JS code. The JSI stuff's really, really powerful, and it's taken over the React Native world. React Native looks set to become the most engine-agnostic JavaScript runtime around, as Microsoft, CallStack, and the React Native community, myself included, are currently working hard on delivering support for the Node API, which is supported even more widely than JSI. Considering also the first-class native code interop promise to come with Static Hermes, it's come a long way since its roots as a single-engine message posting runtime. But how popular is it compared to WebView-based app development frameworks? I love that Evan Bacon is being cited here too. All my nerdy JavaScript friends are coming up in this article. This is great. Evan Bacon reported that by 2023, only 74 of the top 2,500 iOS apps were using Cordova or Capacitor, and in fact, mostly still use the former. Even though Capacitor replaced Cordova 8 years ago, Cordova is still more popular just because these apps aren't being maintained. They're still being installed, but they're not being maintained. It's like weird banks and shit, probably. Whereas by 2025, 30 of the top 100 iOS apps were written in React Native, compared to only 3 WebView-centric apps. RevenueCat, which is the leading in-app purchase solution used by over 50,000 apps, reports that React Native is on track to becoming the most popular app development framework using their platform, with 34% of RevenueCat using apps being based on it, and fewer than 1% being accounted for with frameworks such as Cordova. I can't imagine anyone's actually making money with Cordova or Capacitor. You might have a thing that already makes money and you give them a shitty WebView portal to it via Capacitor. Your bank makes money as a bank and somebody whipped together this app 8 years ago and you're still shipping it because you need something. That would make sense. Yeah. And now we have desktop. This is still the React Native section, right? Yes, it is. Cool. React Native on desktop. This will be a fun one. It's a rather different story for desktop platforms, however. While Microsoft maintains fully featured implementations of React Native for both Mac and Windows, yes, Microsoft maintains React Native for Mac. You know how Apple feels about supporting developers. The ecosystem for the platform is a small fraction of what it is for iOS and Android, with just 20 native modules in the React Native directory indicating support for desktop, in contrast to the 1,700 for mobile at the time of writing. This is reflected in the smaller usership, with only around 100 correspondents in the State of React Native 2024 survey targeting desktop, in contrast to over 3,000 targeting mobile. That's a smaller gap between the two than I would have expected. I don't know anyone working on React Native for desktop that isn't working on the platform itself or at Microsoft or really Microsoft. They're doing crazy stuff with it there, and it is really powerful, but it's not powerful for building a full app from scratch necessarily. What it's really good for is things that are more integrated in the OS that Electron doesn't make sense for. Another way of thinking about this is that on mobile, the native application development kit is good. It's not great, but it's good, and we expect apps to work and behave a certain way on mobile. On desktop, we don't have any of that. There are 50 different ways to build apps on desktop, and all of them suck equally. Electron is slightly better than most of those options, and the web is something most people spend time on using their computer. I would venture to guess that if you count Electron apps as web, that 90+% of time on computers is being spent on web, either through the browser directly or through Electron indirectly. Almost 100% certain of that fact. As such, the platform you're building your apps in doesn't necessarily need to use native pieces in order to be a good experience. Whereas with mobile, if you're not using the native UI pieces, your app feels like shit. As such, I think Electron makes a ton of sense on desktop, whereas Cordova makes almost none on mobile. And that's also why we see the gap between React Native and Electron in comparison to the gap between React Native and Cordova on mobile. That makes sense because Electron is a lot closer to what we expect on desktop, and Cordova is a lot further to what we expect on mobile. And if you couldn't have guessed, it is harder to build a React Native app than it is to build a Cordova or Electron app. So the difficulty needs to be justified by the benefits of using the platform. Those benefits aren't as justifiable on Windows unless you're building something built into Windows, like the one that everybody gets mad at me for bringing up because now it's a point of contention, the Start menu. The Start menu should not be fucking Electron, obviously. The recommended meta framework for using React Native is Expo, and it still lacks support for desktop. And while Microsoft has employed React Native in various Office apps and even in the Start menu, it is mainly as a brownfield solution, making small content islands within the apps. For greenfield apps, Electron is very much more in vogue, with hundreds of apps listed on their showcase alone. Some attempts have been made to target Linux, such as React Native Linux, which is a Qt-based fork by Canonical, later renamed to React Native Desktop, which died in 2021, as well as React Native Skia, but none of these see mainstream usage. React Native Skia is really cool, not for Linux, but for allowing you to do crazy heavy animation stuff within React Native and not having to use the native platform. Not really for desktop, though. Electron is presumably the bigger fish, as expected. And then smart TVs. React Native does have significant foothold on the smart TV space, though, with implementations for both tvOS and Android TV seeing popular usage. With the fall of the UI TV, its proprietary UI engine was deployed to 14 different platforms. The leader in the space are now CallStack, deploying to a similarly large stable. Notable React Native apps include Crunchyroll, NFL, Bloomberg, Yahoo Finance, and more. Twitch was even debating doing React Native for TV. They might have ended up doing it. I don't use the Twitch TV app because I don't really use Twitch. Sorry. I only consume media on my phone. Like, as crazy as it sounds, I don't really watch YouTube on my computer. I'll watch it a bit on my TV via Windows with a wireless keyboard. This guy that I have a whole rant about on my second channel. I like using Windows for TV and also for recording videos and not too much else, honestly. But as such, I don't use the TV apps a lot. So I don't know what's going on with the TV app for Twitch. But yeah, the TV app was at some point being rewritten in React Native because the things that they were dealing with before were awful. No mention of PlayStation or Xbox, though, probably because that information isn't traditionally public. It's only public through many weird talks and things. I've been wanting to do a deeper dive for a while, but I don't want to get my friends fired. Just know that the entire PlayStation OS is using React Native in really cool ways, and Xbox is using it pretty heavily as well. Man, it might finally be time for me to be able to go in depth on the PlayStation thing. Soon TM. And now for NativeScript. By no means were native apps a two-horse race between Cordova and React Native, though. NativeScript, which was announced in 2014, came out the door offering 3 separate runtimes with full JS bindings to iOS, Android, and the universal Windows platform. Oh god, UWP. Oh god. Ugh. While the decline of Windows Phone led to the Windows runtime being sunset in 2016, the iOS and Android runtimes continued to this day, standardizing on V8 in 2019, essentially once V8 supported JIT-less mode to enable its use on the App Store. Yeah, because remember, V8, the engine, uses JIT heavily, so you couldn't ship V8 into your iOS and Android apps because Apple would ban you for it. And while the proof of concept tvOS runtime demonstrated in 2015 never took off, the Android Wear and Android TV runtimes have seen use in industry. More recently, NativeScript has increased focus on enabling the runtimes to be used standalone, rather than as part of an end-to-end app dev framework, re-architecting the runtimes as engine-agnostic libraries of JS to native bindings via Node API. The new iOS and Android libraries can upgrade any JavaScript engine to give it full platform access, provided the engine supports Node API, which is quite a long list. Indeed, Node API has been implemented for V8 by Node, Deno, and ByteDance, JSC by Bun, Hummer, and ByteDance, Hermes by Microsoft and Hummer, QuickJS by OpenHarmony, Hummer, and ByteDance. You might be noticing a theme here. Chakra by Node Chakra Core, and JerryScript by IoT.js. While none of the top 100 iOS apps use NativeScript today, the new Node API re-architecture will allow it to integrate with more dominant frameworks like Electron and React Native, responding to pain points of native API access, much like the pre-Node API capacitor integration in 2021. The proof of concept Expo integration by me, oh boy, this is actually by Birch. If you're liking this article, give Jamie a follow because this has been awesome so far. It's really fun when you write an article like this and finally get to the part where you can mention what you did. It's really, really cool. And now for Node. While the above-mentioned runtimes each form part of an end-to-end and usually cross-platform app development framework, Node has mostly been employed in native apps just as a tool for accessing the Node.js SDK and/or native add-ons, with little success getting involved with creating graphical user interfaces. It wasn't until nearly a decade after its release that Node was ported to mobile, work that was undertaken by Genea Systems in 2017. One of the major obstacles to deploying on iOS was that the App Store did not allow apps that used JIT. Genea Systems worked around this by forking the Node Chakra core, a Microsoft project that swapped out V8 for Chakra core to run without JIT. This was a fashion at the time, with Spider Node adopting SpiderMonkey, Node.js adopting the JavaScript core, which led to Node Native Script the same year, demoed here, and Node JerryScript adopting JerryScript. Genea Systems were eventually able to adopt V8 once JITless mode propagated from V8 in 2019 to Node.js in 2020. Although they had demoed using Node alongside React Native as early as 2017, it never really caught on for that use case, as Node for mobile remained a small player in mobile app dev. Continues to see usage, however, with the baton passing from Genea Systems to a new fork by Andre Staltz in 2023. Besides Genea Systems port, Samsung created their own lightweight node in 2021 based on their earlier engine Escargot from 2016 for mid-range devices such as mobile phones, tablets, and TVs, which probably sees usage on Tizen OS, though the project may not see much use outside of Samsung. I'd be very surprised if anyone else was touching any of that. On the desktop side, there have been countless libraries to expose native app development functionality via Node. For macOS AppKit, there's been Node Objective-C, Obj-C from 2017, and NativeScript in 2023, for examples. For WinRT, there's been NodeRT, echoed by the Deno-based Deno WinRT in 2023. And for Qt, there's been NodeQt, Node-Qt, and NodeGUI. Despite affording full platform access, though, none of these have taken off as end-to-end development solutions even close to competitive with Electron. This has been an incredible article. Quick summary here before we go to the conclusion. JS has ridden the wave of the personal device boom like no other programming language. While motivated to break free of the browser to make full use of native APIs, no framework has been successful in departing fully from the conventions of the web platform, with GUI programming still being firmly inspired by browser APIs, as with React Native, if not entirely delegated to web views, as with Electron. So for the conclusion, developers want to run JavaScript in every context possible, and over the last 10 years, they have raced to do so. From previously being confined to the browser, now the language is seen in basically every device category, and in serverless contexts, people are even paying to execute it. JavaScript runtimes exist to cater to all manner of resource constraints, from the cheapest chip to the meanest machine, though perhaps with less of a foothold in supercomputers, which did not come up during this research. There are great options for interop with other languages, often to facilitate access to system APIs, with frameworks like React Native making extensive use of this. Lastly, JS continues to show its strengths as a language for GUI programming, being employed in a variety of ways to develop native apps on mobile phones and smart TVs, though with WebView-based apps still being the vogue on desktop. Why is there no one best runtime then? Simply, with so many different contexts to run JS in, there are just too many conflicting factors to optimize for. Startup performance, runtime performance, bundle size, API support, and ease of native access all fight for priority. While the browser native engines V8 and JSC have maintained their popularity outside of the browser, they are beginning to face competition from runtimes based on new engines such as Hermes and QuickJS in certain areas. But healthy competition and freedom of choice are only ever good things. The old guard are forced to innovate, and a high standard is maintained for newcomers. For devs, it's the most all-purpose language one could learn and the single safest technology choice for the future. Absolute banger ending. No one ever regretted learning JavaScript. You might sometimes regret picking it, but it's a useful thing to know always. Oh boy, an addendum. I started writing this article in April of 2024, stretching the limits of Buttondown's edit history at over 5,260 revisions by August, before continuing to hack away on it on and off for another 12 months. Even now, I can hardly call it finished. I wanted to do the subject justice, but there's just too much to cover. You've done this so much justice, Jamie. I am really, really impressed with this. This is the best overview with the right level of detail I could fathom. Phenomenal work on this. I understand it'll never feel like enough because you've seen all of this and you want to make sure every single thing gets represented, but you've done a better job than I thought was even humanly possible. So just be proud of it. During the course of writing, a few new runtimes were released. Most notably, ByteDance announced the cross-platform framework Lynx, whose same name runtime is based on their new Prim.js engine, which is based on top of QuickJS. I've not had any time to dig into it, but I can say it fascinates me that the runtime additionally supports JSC, QuickJS, and V8 through Node API. Curiously, while Android defaults to using Prim throughout, iOS defaults to a mixture of Prim on the main thread and JSC on the background thread. This makes it rather an oddity amongst all other runtimes covered here. I have a whole video on Lynx that is a really interesting pile of technologies. And by focusing too hard on non-browser contexts, I appear to have embarrassingly omitted libweb, a browser engine, including a JS runtime, based on the libjs engine for the up-and-coming Ladybird browser, which I've been following closely. Besides those, I have a list of honorable mentions that I simply didn't manage to weave into the story, though admittedly with some being outside of the last decade boundary, like GJS, Mu.js, JS for Automation, Ducklove, Napa, Tixie, Bear, Low.js. Low.js I thought made it in. No, it's a different Low.js. God damn it. With that, thank you for reading. I hope this article raised awareness. Again, I will absolutely be subscribing to this. I recommend you do as well. And also, seriously, give Jamie a follow. This was an incredible article, and he deserves all the support in the world and more. If there was a pay me button on the bottom, I'd be clicking it right now. This was awesome. I don't want to waste any more of your time, so we'll end it here. Thank you again, and until next time, keep running that JS.